Hello, welcome to Praasy Technologies. I am Prakash. In this session, we're going to see about what is SQL data compression. We will understand why we need data compression. Let's start with a simple query. Select star from employees. When we execute this query, it will retrieve records. But day by day, when we keep on inserting records, millions of records will be added into the table, and in parallel, size of the database will also increase exponentially. When size is less, the performance better and cost of storage will also be minimal. When size of the table increases, of course the performance reduces and cost of storage varies. So MS SQL has introduced a feature, data compression, so we can apply this feature on our existing or new tables where we can reduce size of the tables from 30 to 60% without impacting the data. If existing size of table is 100 GB, it can be reduced to 60 GB after applying data compression feature. Let's understand the benefits of data compression. It reduces the storage space. In turn, it improves the I/O efficiency and improves the performance. This can be configured on tables, cluster or non-cluster index. Even this can be implemented on indexed views. This is supported from SQL Server 2008 version. Yes, of course, this is supported in Azure SQL, but this is not supported in Azure SQL GW. Data compression is of two types. One is the row compression and another one is the page compression. Let's see what is row compression. If character column has trailing spaces or null characters, they will be optimized. If integer column has prefix zeros, then those zeros will be optimized. Row compression is supported on the below integer, character, Unicode data type and money data types, but this is not supported on tiny int, small data type and varchar and few of the data types. Let's see about page compression. It includes row compression and also it includes two algorithms which are prefix and dictionary algorithms, which we will be seeing now. Before going to the demo, let's see with an example how it actually works. Let us consider a table which has three columns, name, product and country, and it has few records in it. In the background, SQL data compression has two algorithms. These two algorithms will be applied on this table. First one is the prefix algorithm. This algorithm is applied on each and every column of the table. The next one is the dictionary algorithm. This algorithm is applied on the whole table. First, let's see how prefix algorithm works. This inserts a record called anchor record on this table. Now let's apply prefix algorithm on the first column, name. As algorithm name itself says prefix, it checks for any prefix letters getting repeated in the name column for all the records. Yes, we can see that BI letter is getting repeated in all the columns, so it pushes prefix letter BI to the anchor record. Then it replaces with index size 2 of anchor record in all the respective records of column name as 2, which means that first two characters of anchor record are replaced there. Then it again checks for any prefix letters getting repeated. Yes, L is repeated, so it pushes L to the anchor record. Then it replaces 2 with 3, meaning the first and second record, first three letters of anchor record is pointed here. Then at last it checks which record has the least size. You can see the second record has least size, so it pushes L to the anchor record. We assume it replaces size 4, but that's wrong. It creates an empty record, meaning whole anchor record points in second record. Prefix algorithm applied on name column. Now let's apply the same on product column. It checks for any prefix characters getting repeated. Yes, it's C. So it pushes C to the anchor record. Then we can see OL is also getting repeated, so it pushes OL to anchor record. Now it replaces with the index size 3 in the first record and 3 in the second and 1 in the third record. Now size of record 1 is smallest when compared to the 3 records, so it pushes A to the anchor record and replaces with empty. Now we're gonna apply prefix algorithm on the third column. You can see USC is getting repeated. It pushes the anchor record and replaces with empty. Now we are going to compare the size of the table before compression and after the prefix algorithm. Let's say before compression the size is 41, which means that only 41 characters has been used in this table. Let's count the size of the table after compression with prefix algorithm, and these are 4 characters and index as considered as 1 character. So 5 and 9, this one is 10, 14 and 15, 18, 19 and 22. Now the size has been reduced to 22 from 41. So we have seen what is prefix algorithm and what is anchor record. This prefix algorithm applies on each and every column. Now we are going to see what is a dictionary algorithm, and it will have a dictionary record, and this dictionary algorithm will be applied on the entire table, not on column wise. So this dictionary algorithm will checks for is there any words that's getting repeated in the table. As we can see that 3 of get is getting repeated, so it pushes to the dictionary record and gives a unique name to it. Assume it could be A1, so it pushes A1 to the respective records there. Then no other words getting repeated, so the dictionary algorithm has been applied on the entire table. Now compare the size of the table. So before compression it was 41, then after compression with prefix algorithm it has been 22. Now let's see the size of the table after prefix dictionary, and this is 1 character, and 2, 6, and this is 7, 10, 11, 11 plus 3, and it has been 14. There you can see that the size has been drastically reduced from 41, 22, and now it has been 14. So before compression it was 41, so after applying all these algorithms the size has been reduced to 14. Now we are going to see a demo on data compression that would be applied on a table in Azure SQL. Let's log into Azure portal. We have logged into Azure portal. Search for SQL Server in the search box and click on SQL servers, and we have an existing SQL Server, that is Praasy SQL Server. Click on it, and we are going to copy the Azure SQL Server name here. So copy this, and we are going to connect Azure SQL in SQL Server Management Studio. We have logged into SSMS. Let's connect and copy the Azure SQL Server name which we have copied in the Azure portal. Give the credentials and connect, and Azure SQL has been connected now. If you do not know what is Azure SQL Server, and if you want to create a new Azure SQL Server in Azure portal, then verify my earlier tutorial how to create Azure SQL Server, which is in the below description. We are back to the demo and click on databases, and we have a database called PraasyDB where it has a table with millions of record, and we are going to execute this query. Don't worry about this query, and this gives the details of the table. So the table name is table million, where it has 1 million records and its size is 68 MB, and this query gives you whether it has data compression applied or not. We can see that data compression is not applied, which is none. So on this table we are going to apply data compression, and let's see how the size will be reduced from 68 to compressed to minimal size. Now let's analyze the table. So we have the table million, so we are executing top 3 records, and we have that there are a few columns available here. So let's see the size. So its size is 70,000 KB. So we have already created a query, so execute this where it shows the exact value in MB, and you can see it is 70,000 KB, which is 68 MB. We're going to apply data compression on this existing table million, and this is the query where we have to specify data compression as page. So when you specify page, it also includes row, as we discussed earlier, and just execute this query. So it's executing. As you can see that it's successfully completed, Let's see whether data compression has been applied on this table or not. So go back to the previous query and execute this. So you can see that the size has been drastically reduced to 49 and the data compression indicator has been 2 now, and even you can see the description that the data page has been applied on this table. So we remember that the earlier size was 68 and this has been reduced to 49. We have applied compression on an existing table. So let's see how to apply compression on a new table, and this is the query. So while creating a table, you have to specify so what kind of data compression are you going to specify here, and just execute this. So the table has been created with page compression. Now we're gonna write a query how to identify compression on an existing table. So we are going to join sys.partitions and sys.tables, and this is the query. So we are going to search for the table test. So execute this query, and this would give the details of whether compression applied or not. You can see that data compression has been applied. 2 specifies page compression, 1 specifies row compression. All the scripts are available in the description. You can refer from there. So in this way we can apply compression on an existing table or even on the new table. Now we're gonna compare the results of the table before and after compression. And before compression you can see that the size is 68, and after compression the size reduced to 49 MB. And before compression you can see that the indicators is 0 and the description is none, which means that there is no compression applied on this table. And after compression the indicator has been changed to 2, which means that page compression has been applied on this table. But you can see that the record count does not change, it remains the same, which is 1 million. We have come to the end of this session. Please check for the scripts and links in the below description. Thank you. Subscribe to my channel for more videos. Have a great day.